Hi, good evening to you. Welcome to the weekly Python show. Now, you have noticed there is a sort of weird moment. There is silence where the drum's supposed to be. Problem is, today Boosted Boris is not with us. However, could be that we have thought of something else. Yes, absolutely. First, I want to say big thanks to the person who posted in comments last week, on last Thursday, software called, I don't remember actually. So the software for bands. We tried it, we installed it. It's great. It's really great because it's open source, it's free, and it's easy to install, and it's cross-platform. And this is crazy. I totally would not expect it. Gemulus is the name. And now you can hear it, hopefully. So maybe next week, Boosted Boris will use it as well, hopefully. Today, it's Gena. Gena, are you here? I love it. I love it. Yeah, the problem is it only transfers audio, obviously, software for bands. So maybe next week we can come up with some solution combination with Skype so that we can see you again as well. But for now, hearing you is such a joy. So today we have a really cool program. Today we have one topic. It's essentially hacking the Python runtime. And we have two awesome, super great speakers who will be showing us some presentations on this topic from different sides. On one side, there will be Lisa from JetBrains. On another side, it will be Emanuil from Elastic. So I'm absolutely looking forward to hearing these talks, but first I will quickly go over what has happened last week, as I always try to do for you in the world of Python. So first, the first beta was released of Python 3.9. I will not go over the features. To be honest, I didn't even read them. But I'm thinking that I would be taking a good spot for some other speaker. So let's leave it for the future episodes. But what I can tell you about a bit is about Django 3.1, which was also released, but that was alpha. I think that was the first alpha. It was not beta. Django is doing really well going to the async execution model. Like this is what we have now. We can do. You can use native coroutines in Python. We can use async def in the views. We can do async tests, and we can have async middleware. If I'm not wrong, this is really great news. I'm looking forward to next releases and to putting this thing in production. Next, PSF is still looking for the volunteer and contractor for moving issues like Python bugs from the old bug tracker to GitHub issues. So if you are interested in doing some work for the world of Python, please apply. Links are in the description. Then finally, EuroPython. We all know it's live. Last time I promised you Marc-André on the show, and this is happening next Thursday. He will join us. For now, I want to advertise the CFP because it's closing on May 24th, which is in 3 days. So make sure you apply if you want to participate in the main European Python conference. By the way, it looks a bit weird that I don't see any complaints in comments of not hearing me or hearing the echo or hearing the noise. I'm so used to it. So please let me know if everything works just fine or you don't see anything and that's why you don't comment at all. Then, what else we have? I have noticed a not really good situation on the market that people are getting cuts, laid off by their employees. If this is a hot topic, please post in comments or contact me privately. I'm thinking of gathering offerings, at least for Munich, maybe for Germany, maybe even more. If that is relevant, I can do a quick recap of the companies which are hiring in this time, because there are also companies hiring, also in Munich, many of them actually. So it's just about mapping people to the headhunters. So if you are interested, I can do that. Good. I think we were through with the news. I'm actually a bit bored of looking on my own face. So I will be now starting with the first talk by Elizaveta, or as she asks to call her, Lisa, simpler version.
Yes.
Hold on a sec. I need to turn on you. Video. Oh my God, this is epic. Oh, Lisa.
Hi.
Hi. When you will be watching this stream, you will understand what I mean. Lisa, we are very happy to have you. You are unmuted. We can hear you well. How are you doing?
Great. Hi, Anton. I'm very happy to be here too. I'm fine. Thank you very much. As fine as it is possible to be during the worldwide pandemic. Yeah.
Oh,
But yeah, I'm fine. Thanks.
ironic. Uh, do you still have the white nights in St. Petersburg?
Yeah. This is exactly the season when we have these white nights. Yeah, when it goes dark very late and uh, light returns very early. Yeah. And usually we have a lot of tourists here in St. Petersburg, but not this year. Yeah.
I see.
Unfortunately.
Because
Next year, come come to St. Petersburg in May. Yeah.
last week we had Irina from St. Petersburg, and we've been just surprised that at the end of the show, it's dark everywhere, but we see her window and it's light. That was a
Yeah.
funny
Here is my
experience.
window too.
Nice.
Yeah.
Lisa, so you are working in JetBrains. Can you tell a bit of what you do, like your daily work, the project you're working on?
Yeah, I'm a software developer. I'm working at JetBrains on the PyCharm IDE. I've been working on Debugger in PyCharm for several years, well, quite many years. And now I'm focused on scientific tools in PyCharm because this area becomes more and more popular every year. And we're doing our best to make PyCharm comfortable for our data science users.
Nice.
That's what I'm doing.
When are you coming to Munich next time?
Usually we have a team gathering every year in Munich in spring, usually in April and
Ouch.
May.
I guess didn't work
Yeah.
this time.
Yeah, this year we skipped it, of course, obviously. But I hope next year, yeah, we'll come to Munich and have fun together.
So when you come to Munich next time, I will catch you for Pi Munich meetup. I hope we will not have any lockdowns by that time and we can resume also normal meetups, and that's where we would be happy to see you again. But for
Yeah.
now, let's enjoy what have you prepared for us. So what will you be talking about today?
Today I'll give a talk about the hidden power of Python runtime.
Wow, that sounds good. Hidden power of Python runtime. Did you work with these tools actually on PyCharm, or how do you know it? It doesn't sound very common.
Yeah, in fact, Debugger is, well, I think we can call it runtime tool because it analyzes current runtime state during program execution. And also there are some other tools, yeah, which are also very interesting. Some of them are supported in PyCharm, integrated in PyCharm. And yeah, I think it's a very interesting topic anyway. So that's why I decided to give this talk. Yeah.
Perfect. All right, then I guess I will have more discussion with you after your presentation. For now, I don't want to interrupt you. Please start the screen sharing. I will start it here as well. Okay, let's see.
Cool. Yeah. Okay. So let's start with my talk. As I've already said, I'm a software developer at JetBrains, working on the PyCharm IDE. Currently, I'm located in the Russian city St. Petersburg, recording this talk from my home, like everybody else in the world. And here is my Twitter. Feel free to follow me and to ask questions there directly. Python is very simple and very beautiful language, but where a big part of its power is hidden from the user and available only during execution, only at runtime. You might even don't know about it, but you already use this power every day. For example, we run tests every day. The two most popular ways to do it in Python are built-in framework unit test or popular testing framework PyTest. When something is wrong with your assertion, and when you get an assertion error, Unit tests just prints your exception traceback as any other traceback in your Python program, like, well, something went wrong, here is the message. But PyTest does it differently. It prints not just an error message, it also shows you which values, for example, you tried to compare and what's wrong with your assertion statement. Where did PyTest get this information? It got it from the runtime. And today, during this talk, we will learn which interesting information is stored inside Python runtime during code execution, how everybody can get this runtime information inside their code in any part of their program, and also we will learn which development tools can be based on this runtime information and how they can help developers in solving their everyday tasks. Let's start with basic concepts of the Python runtime. There is a popular phrase that everything is an object in Python. What does it actually mean? It means that every object in Python, not just a piece of memory, but a complicated entity which connected attributes and related methods. And it's true not only for core types like numbers, strings, collections, and other things. It's true also for program unit objects, like, for example, functions, classes, and even modules. When you create some variable, when you use assignment statement or keyword def or keyword class, a Python interpreter creates object corresponding to this entity. All these variables, all these objects are created explicitly. These variables, functions, classes, because you write code which create them. But Python interpreter creates not only this explicitly created objects, but also util objects, which are created implicitly. And the key object among them is a stack frame. Stack frame represents a program scope. It contains a lot of useful information, like corresponding code object, local and global variables, and a lot of other data. Frames are stored in a stack-like structure. So you put each of them on top of another. And the bottommost frame is called module frame. It represents the frame from which the execution is started. So, for example, here, execution is on the line 7 inside the function bar, and Python interpreter is going to call function foo. What happens when Python interpreter executes this code? It creates a new frame corresponding to the function foo and put it on top of other frames. Then it executes some code inside function foo, and when execution leaves function foo, interpreter removes our newly created frame, and the data returned from the frame goes to the previous frame, to the function bar, and execution continues in this function. This is very simple description, and this stack frame machinery is not unique for Python language. It's available in many other languages. But the most important difference between them is that not so many languages allow you to work with these objects out of the box. Because in Python, you have access to a stack frame object. It's just a usual Python object. You can create a local variable with it and inspect values and data, which is stored inside this object. And this is really great. In the next part, we will learn how everybody can get this information from a frame object. The easiest way to do it is to call a function getFrame from the standard module sys. It has an argument, a number of calls below the top in our stack frame. So if you pass 0 to this function, you will get the current frame object. And which interesting information is stored inside our frame object? First of all, it's a dictionary of local variables. So it's stored in this flocals attribute, and it's a dictionary where keys are variables names, just strings, and values are variables objects. Frame also stores global variables, similar dictionary, but which contains not local variables for the current frame, but global variables. Global mean for the current module. And that's great, but to be honest, it's not very useful because both these dictionaries, we can get them from the standard functions locals and globals, which return exactly the same dictionaries. And in fact, we don't need frame object to get these dictionaries. But the good news is that frame contains much more interesting information. For example, it contains a code object. It's stored in fcode attribute, and a code object represents a chunk of executable code, but it differs from function because it doesn't have reference to global execution state. It's just a local thing, local object. The easiest way to create it is to call built-in function compile. You can see here, we compiled this expression, a plus b. It returned an object. And for example, we can evaluate value of this object. So we pass a dictionary with variables values, a and b, and Python return us the value of this object. That's great. What is stored inside code object? First of all, it's a file name where this code object was created. It also stores a name of a function where it was defined, names of variables which are used inside this code object. It even stores a compiled bytecode, compiled bytecode. This is just a sequence of instructions generated by Python interpreter, and you can disassemble it with built-in function dis. So you can just disassemble it and read exact instructions which were generated by Python interpreter. That's cool. If we return to frame object, we will also learn that it contains information about, for example, current line number, or about tracing function defined for this frame. We'll discuss it later today. And even contains a link to the previous frame. This is also very interesting because, as far as you remember, frames are stored in a stack-like structure. And when you get, for example, exception, and when you see traceback of this exception, you can see this, frames which were used during this traceback generation. And fback attribute is exact value which helps Python interpreter to build this detailed explanation how you get to this place in your program. Okay, I've mentioned just the most important attributes or information stored inside a frame object, but of course there are much more interesting information. I just don't have time to mention it today. But there is a built-in module inspect. It has a separate group of functions which allow to inspect different fields inside a frame object. But the most important thing, which you should remember when you work with a frame variable, is that you should work with it really carefully. You shouldn't forget to delete this variable when you're leaving scope, because as you remember, frame has a dictionary of local variables, and if you created a local variable which is frame, it has a link to the local variables dictionary, and it contains a local variable which again has a link to the frame object. So you get a reference cycle, and it can lead to memory consumptions. So don't forget to delete it. It's really important. Okay, now we know some important things which are stored inside frame objects and code objects, but that's cool. How can we use it in our everyday life? Because, well, it's just some parts of Python interpreter. Why should I be interested in it? Development tools there are a lot of them, runtime-based development tools, which use this runtime information. First of all, in the beginning of my talk, as you remember, we've learned that PyTest shows detailed information about assertion error. And let's try to understand how it is implemented inside PyTest. First of all, every exception stores a traceback object inside its dunder traceback attribute. And each traceback object has a link to a frame object. And as we already know, frame contains a lot of interesting information. Let's try to get, for example, variables names and values, which are used inside our failed assertion statement. So, for example, here, we know we can get traceback object and frame object from our exception. Of course, from the code object, we can get line number in the current scope where exception appeared. And with the help of inspect module, we can get the source code of this, for example, function. Okay, after that, with the help of the module AST, its standard module, we can get variables names which are used in this source code on that line. I don't show this code here because it's, well, quite big and quite boring, but it's, well, quite simple at the same time. Okay, and when we get variable names, as you remember, in the frame, we have a dictionary of local variables. So we can find variables with our names and get their values and print them to output. So now, how can we use our vars in assert function? If some exception happened, assertion error in our case, we pass an exception object to our function, and it prints variables names and their values, which were used inside this assertion statement. Of course, it's our function is not as smart as PyTest because it's a big, powerful framework, and we implemented just a simple project. But now we understand how it works, and the general ideas are very similar to PyTest's implementation. Okay, let's move to the second tool. The second tool is Debugger. As I've already said, I've been working on PyCharm's Debugger for several years. That's why I know so much information about frame objects, code objects, and all these related areas. Modern debuggers are usually based on two functions. It's a tracing function and frame evaluation function. Tracing function takes 3 arguments, frame, event, arg, and it allows you to inspect events which happen in your program. You can define set tracing function to the current frame, which will be stored in the frame attributes of trace. And after that, debugger analyzes events which happen in your program and suspend your program or resume your program or do something based on this information. The second function, frame evaluation function, takes arguments frame and exception, and debugger started to use it starting Python 3.6 because this API appeared in this Python version, and a frame evaluation function is being executed before frame object is created. And how debuggers use it? Debugger inserts breakpoints code right into code object in the frame. So to stop at some place where you put breakpoint, there is no need to trace every event in your program. The corresponding function will be called automatically when execution goes to this place. In fact, I'm not going to discuss it in details now. Feel free to check my PyCon US talk, Debugging with Python 3.6. But what we are interested in today is that both these functions take frame object as an argument. That means that when your debugger works, it has access to frame object. And what can debugger do with this? information, it can do a lot. For example, a debugger can get location of the place where your program is suspended currently. It can get file name and line number and highlight the corresponding line in your favorite IDE. Or you can get local variables values from the frame flocals dictionary, which is also very useful. Or when you see the stack frames, the list of frames which shows you how you get to this place in your program, Debugger just iterates over fback attributes inside your frames and shows you this information. So this is how Debugger can use a lot of information available at runtime, but hidden from user. The next tool we are going to discuss is a code coverage. Code coverage shows you which lines of your code base were executed when you run it under coverage. It is very useful because it can help you, for example, to understand which parts of your code base are properly tested and which are not, because you can run all your tests with this coverage and it will generate your report and show you which lines were executed and which weren't. It is very cool tool. It makes your code base really reliable. And the most popular way to do it in Python is coverage.py. They have extremely cute mascot, Sleepy Python. And coverage.py is also based on the same tracing function, which we've already seen. So it has access to a frame object. And with the help of frame object, it can get a file name and line number, which was executed. After that, it can store this information to a file and to your coverage report and show you later. Great. So not even debuggers, but even code coverage use a lot of runtime information. And the last tool even group of tools we are going to discuss today are runtime typing tools. Runtime typing tools, I found information about 3, the most popular of them, I think. What do they do? They are PyAnnotate by Dropbox, MonkeyType by Instagram, and collect runtime information feature in PyCharm. PyAnnotate collects information during your code execution and automatically generates type annotations for your arguments for your functions, which were called. MonkeyType generates stub files with a similar type annotations for called arguments. And collect runtime information feature is integrated with Debugger in PyCharm, and it stores, again, typing information. And when you decide to generate a docstring inside PyCharm, it suggests you to use times which were recorded during execution. Okay, let's learn how these features are implemented. PyAnnotate and MonkeyType both using a profile function. Profile function is very similar to tracing function. You can see it takes exactly the same arguments, frame, event, and arg. And again, you can define this profile function for the current scope. But tracing function traces every event which happens in your program, but profile function traces only call events. So every time when you call some function or enter a new scope, this event arrives to this function. And it's logically because for these tools, we want to record only function calls to get argument types. So that's why they use profile function, but not tracing function. And collect runtime information in PyCharm, as I've already said, it's integrated in Debugger. So it also has access to a frame object. Okay, how can we get arguments types from the frame object. It's quite easy to do in Python, to be honest, because frame object has access to a code object, and inside a code object we can get arguments names, which are used inside current function. And as you remember, we have a dictionary with local variables, so we can get their values and therefore their types. That's pretty simple, but really useful. This is how all these typing tools are implemented, again with the help of a frame object and corresponding code object. That was the last tool which I were going to show you today. Today we've learned a lot of new things. First of all, we've learned that Python runtime is really very powerful, and in Python you have easy access to a stack frame and code objects and a lot of information, which is usually hidden from user, but it's available in any program, in any place of your program. So there is no need to pass additional, parameters to your interpreter or configure libraries. It just works out of the box, and it's great. And as you already know, there are a lot of really cool tools which use this runtime information, which I mentioned today. And I hope today during the second talk, you will also learn a lot about other tools which also can be built in Python and for Python. And I hope that after this talk, you will start using existing runtime tools or start using them more often if you already use them. And maybe one day you create something new, who knows? Because, well, these tools make you really productive and help a lot of developers. And I think you can create really something great and powerful. Here is the link to the repository where you can execute examples, which I showed you today, and maybe improve them somehow. Of course, feel free to read official documentation. It also has a lot of useful information. And I'll always be happy to answer your questions by email or on Twitter. Thank you very much for your attention, and goodbye.
And bravo, bravo, bravo.
Not goodbye.
Bravo, bravo. Thank you. It was a great talk. Yana, can we get some support, please, here? Yes. Thank you so much. It was crazy. It was very detailed.
Thank you. Thank you very much.
I was afraid to lose it. I mean, I need to prepare some technical things here on this side, but I was feeling like if I stop watching for a minute, I'm lost. So I'm sorry if something won't work. I was just watching the talk myself. That's how it's going to be today.
That's great.
Thank you. Crazy. Very good content. Thanks.
Thank you very much.
Okay, so if you have questions to Lisa, please drop them in comments. Meanwhile, I will ask my questions. Lisa, there are so many debuggers in Python itself. There is classic PDB, there is IPDB for IPython, there is PDB PP, PUDB. They perhaps all use the same thing, what you've just told us about, right? Or is there anything that stands out from the standard debuggers?
Standard debuggers, they use the same tracing function, which I showed you today. Yeah, but they're usually very, primitive. They're reliable, but they don't have a lot of, cool features. Because in PyCharm, we have our own implementation of debugger. And in fact, we share debugger backend with PyDev, the Python IDE for Eclipse. You might have heard about it. So we have the common backend. We share, for example, our bug fixes or features with it. But in PyCharm, we don't use PDB. We use our own implementation, and we had a lot of cool features like, we attach to subprocesses automatically. We, of course, attach to new threads. And so you can put breakpoints in the threads, and debugger will suspend the we have a lot of cool features, like you can inspect variables or start interactive REPL session while the program is suspended at breakpoint, and do a lot of cool things. Yeah, so our debugger is much more powerful. Yeah.
Nice. Thanks. I see there is one question. I'll just show it now. So are those APIs considered public? Was the question. I don't know what exactly public means. I guess, is it too hackish to access them? Are they underscored? Are they hidden somehow?
Yeah, I don't understand which APIs exactly. Yeah, because tracing function and frame evaluation function and profile function, which I mentioned, yeah, they're part of public API. Yeah, you can implement it. You can implement your own debugger or your own profiler, for example. Yeah, it will work with your Python programs. Some other functions, inspect module, which allows you to inspect frame variables. It is also part of standard library, so you can use it, and everything will be fine, I hope. Yeah, but just don't forget to delete your local frame variable, and yeah, everything is part of public language API, so it's available for everybody. Yeah.
Very good. Next. I have my personal question. It's again back to standard debuggers. It's a bit stupid,
Yeah.
but I was always wondering, if this new, the breakpoints function is the same as the import PDB set trace, or is it doing anything else? Is it really a new debugger or just an alias to the old one?
No, it's not an alias. It's new because when you use import PDB set trace, you start tracing only from this place. So if, for example, your program already running, with PDB, you can't add breakpoint during execution. You should wait for stop, and only after that you can execute some command or do something, evaluate some expression. But in PyCharm, we start tracing from the very beginning. So even you start debug session, but you didn't add any breakpoint, and you can add it right during execution, and debugger will stop at this breakpoint. And
Okay.
this is the cool feature of visual debuggers, because, well, when you start something from terminal, you can't just send this command to debugger that you want it to stop here. But in visual debuggers and in PyCharm, you can just add breakpoint right during execution, and it will be handled by debugger. Yeah.
Okay, thanks. That's nice. Good to know. I have one more question, but first let's go in comments. Let's be fair. We have more questions in comments. Could you please explain again how do you handle frame carefully and why you delete it?
Frame what? Frame?
How do you handle the frame carefully and why do you delete it?
Because as I don't know, maybe I can return to this place. One moment. Oh, no, where was it? Yeah. So here, when you created local variable, it's a frame local variable. So in fact, it's a link to your frame object. And as you remember, frame object has a dictionary of local variables. So frame has a dictionary of local variables, and this dictionary contains a key called frame, which also has a link to this frame object. You see, there is this reference cycle to objects, and they have a link from one to another. They link each other, and that means that their reference counter will never go to 0. In Python, objects are usually destroyed when their reference counter is 0. That means that there are no other objects that refer to this current object. But in this case, we'll get a reference cycle. These objects refer to each other. That means that this memory, which was these objects will stay alive much longer, and they will be removed only when garbage collector will be started, will find them, and will understand there are no more references to these objects inside this cycle. Because it can lead to memory consumptions, and that's not great. So you should delete this variable explicitly. So you break this cycle of two objects in your local scope, and there won't be memory problems here. That's it.
All right. Thank you very much. Maybe one last question from me. I guess I'm feeling really sorry because I promised next speaker to start at 19, but chatting with you is so interesting. I think we can have one more. Okay, one more. It's about remote debugging, a common problem in the world of the cloud systems. We deploy, I don't know, Azure or Amazon Lambda serverless application. We want to debug it, we can't because it's not local. I know that there is a remote debugger. Do you have something like that in PyCharm, or how does that work?
Yeah, we have remote debugger in PyCharm. It works, well, quite simple because debugger in PyCharm consists of two parts. The first one is a UI. It's written in Java, it's JVM, everything you see in UI. And the second part is backend. It's written in Python. And this is backend which we share with PyDev, Python ID for Eclipse. And the cool thing is that they have a socket connection. There is a socket connection between them. So when you want to debug something remotely, we just send this Python part, Python backend, to your remote machine. The established socket connection, and you can debug something remotely. But for you, visually, it will be the same as you debug it locally. So the backend is the same, UI is the same. The only difference is that this backend located not on the local machine, but on the remote machine. And this is how it works. Yeah.
Sounds indeed simple. I'm sure it's not. Okay,
oh,
Lisa.
yeah, the main idea is simple. Yeah.
It was great listening to you, and also thanks for answering the questions. I'm sure everyone appreciates it a lot. I hope that the lockdown will be over soon, and maybe you can visit your Munich team, and then hopefully we can meet you in person here.
Yeah, that would be great. I miss the whole Python community so much.
Absolutely. Good. Thanks for your time again. And let's go to the next speaker. The next speaker.
Hello.
Hold on.
Tom.
Let's let our musician express himself. Thank you. I'm sorry we're doing it the first time like this.
It's okay.
The next speaker is Emanuil. Oh wow, we put you on fire now. I guess we need some more action here. Oh my god. Okay, Emanuil. We've met last time on PyCon Odessa, right?
Yes, I did.
Very good. Do you plan coming again?
Yes, as soon as possible. I hear it's maybe happening in September, so I will try to be there.
Hopefully, me too. Emanuil, you do a lot of community work. I've met you there last time, but I have seen that you travel around pretty much a lot. That's part of your work, I guess. Is it?
Yes, it is. Yes. So I'm a community advocate for Elastic, and as part of that, I go to mostly Ruby and primarily the Python community, DevOps community, and yeah, meet lots of people who use their tooling. And I also, totally unrelated, I suppose, to Elastic, I help organize a conference called FOSDEM.
Nice. We know
source.
it. I think PyMunich knows it. Manuel, so how do you work right now? And you can travel.
It's a good question, Anton. I just sit despondently in my London flat and do talks like this in the evenings.
All right. Is there a lot of them? Like many online shows, meetups, whatever, where you participate?
Everybody is moving online now. But yes, the UK has quite a few good Python meetups. So
I see.
Yes.
I was yesterday attending Py Barcelona or something like this. It was very good. The organizers are also good friends. I love this thing that you can just with one click connect everywhere. It's cool. So let's see.
Yeah, yesterday I was speaking at Python Prague, their
Oh my
meetup.
God.
So you could just look it up, and they're very fun people. I recommend joining.
Well, Czech people, of course, they are fun. Emanuel,
Naturally.
what are you going
Yes.
to talk about today?
So today I will talk to you about the gentle touch of APM, application performance monitoring. I'll try to make it look a bit less like black magic. How we get all of those traces and exceptions and all that onto nice graphs.
Emanuel, I'm already wondering if I will have to look the whole talk again, to watch the whole talk again, because I already feel lost, to be honest. This is sort of a side of Python that I think many of us have never touched. We just know it's there. We use those New Relic, Elastic, whatever agents running, and we never think, well, I can only say about myself, but for me, it just works. So I'm absolutely looking forward in how exactly does it work. So good, let's start. Can you turn on the screen sharing, please?
Yes, you should have it.
We have it? Okay, let me
Yes.
then turn it on real quick. Yeah. Okay, very good. It works. Please start.
Excellent, thank you. So, gentle touch of APM. Let's see some code tracing in Python. All right, so before APM, certainly how I started, we used to collect lots of logs. So you would have like one server, and on it you would have maybe a reverse proxy like Nginx, or a web server like Apache, and then you would have a data store in the back, like probably MySQL, Postgres, Elasticsearch, and in the middle you would have your app written in Python. But then you might think, well, having it all on one server, there are resource issues. I would like some more capacity. And so maybe you move the web server, it's the Apache or Nginx, to its own machine, a smaller one in the front. And then in the middle, you still have your Python app. Then in the back, you have your data store. But then you go, well, it's still not really enough capacity. And if one of them falls over, the whole thing falls over. And so you get to having maybe 3 of each for higher redundancy, right? But then you have a problem. So far, maybe you are SSHing into each machine and looking at the logs, but now you can't do that anymore. Well, you can try. And I have kind of managed it with about 9 servers or so. You're still logging in manually. It was not fun. The problem, of course, is if you have 90 or 900 servers, and then it really breaks down. Okay, so then what do we do? Well, there are some venerable old projects like Nagios and Desinga, and there's also tons of others that have now for decades allowed you to collect that information and put it in a central place. And so that you can view all of your logs in one place. Then we kind of did the same thing with metrics so that you wouldn't have to log into each server and run htop on each of them to see what's going on. You wanted historical info anyway. We would collect all of that information, all of those metrics, put them in one central location, and then you could also see the pretty graphs of historical info. So I kind of had to do that. So my story is that I used to to run a small consultancy, a small agency with some British friends. And I have this story where basically I was in charge of the infrastructure for a nonprofit client, and everything had gone like relatively well for a couple of years. But then, and back then we only had logging. So I would log into servers and look at the logs, and we had the metrics. But one day, a problem occurred. The app was sluggish, very, very, very slow. Like it was taking 10 seconds to respond to users. It was a big problem. And then what I tried to debug it. I thought I'd got it with just logs and looking at htop. And then it reappeared again and again and again for the next 4 days. So that was very fun. Yes, not really. So this is when we installed an APM tool, and which was New Relic at the time, because Elastic APM wasn't out yet. And that really saved me, and it really allowed me to finally put the problem to rest and debug it. All right, so what I'm hoping to show you today is to convince you that you're not using an APM, you should use it, and give you some interesting information about how it works in Python. So APM definitely made me happier. Hopefully it makes you happier too. Okay, so we'll talk a little bit about Elastic APM's tech architecture, a bit about how web frameworks work in Python, and then we'll look at some code. Okay. In case you don't know about Elastic, it's a company that stands behind a bunch of open source projects and then some free ones, as well as, of course, a few paid ones. Okay, we have to live as well. So this here is kind of the heart of our stack. We nowadays have even more stuff to do with mapping, security, and more pieces for observability, endpoint security, but tons of stuff. But at the heart of it, this is probably what most web devs will know. At the core of the stack is Elasticsearch, which is an open source analytics and search engine. And then on top you have Kibana, which is the graphical UI, and we will mention those two pieces again. Then you have Beats, which they collect metrics like CPU, RAM, disk, or they maybe ship logs. So they collect all of your log files and they put them into Elasticsearch. If your logs are in text rather than being structured logs, which I recommend you look into, to basically JSON logs. And if they're not like that, then you first the Beats might need to ship your logs to Logstash, and that's the yellow bit on the diagram. And that's kind of like it's just an engine to parse logs. And it's super configurable. Okay, so we end up with the metrics and the logs in Elasticsearch, and then we also end up with application performance monitoring or code traces, transaction info, and so on. But we will have a look at that now. Okay, so this is how APM kind of fits alongside logging and metrics. So with Beats, you have like, including the logs, but you also send metrics and network information and packet information to Elasticsearch. Then you have Logstash for the logs, and then you have APM. And I actually recommend having all three because they will give you a different angle on your infrastructure. But I'll talk a little bit later about, I do have a favorite order for those tools. APM Tech Architecture, like what is it roughly? How does it work at all? Well, let's say you have an app, a standard app. You have a data store, MySQL, and it has a backend, Python, and it has a JavaScript front end. I mean, of course, what else would be the front end? So in the backend, you would install an agent that collects data. It collects how quickly your app is responding to certain URLs, or how quickly it's responding to transactions. And in the front, we have this real user monitoring, or RUM. It's an excellent name. We have this RUM agent. And so they both send their information to a collector called the APM server, written in Go, and that processes the information from the agents and puts it in Elasticsearch. And then we can look at it with Kibana, the graphical UI. Okay, so you can actually download all of this stuff and run it yourself for free, including for commercial reasons, for like no limitations at all, no time, no purposes, no anything. You can do that, but often people have well, you have this problem of who watches the watchers. Like you have some monitoring infrastructure now. Now, who is going to monitor your monitoring infrastructure? So this is why I've shown the server-side stuff running on Elastic Cloud, because you can get, you have to then pay us a little bit, but you can get us to run the server-side stuff, and you just keep the green app bit. So you just have to install it. All right, so let's have a look at an APM. This is Elastic APM, of course. Many are available. It's a crowded market. Okay, so we start here. At first, it will list out all of the services that are reporting to it. So we have support for a lot of different agents. We have Go, Java, .NET, which is not on here. But we have real user monitoring, so JavaScript client side. And we have Node, so JavaScript server side, Ruby. And of course, we have Python. Where would we be without it? Okay, this is another cool thing. In the very newest version, so this is beta actually, there is a service map which shows you, okay, exactly how are those services that we see here in this list, how are they actually connecting to each other and talking to each other? And you can see the language. So like this app has 2 Python services, for example. Right. Okay, but now if we look at the specific Python service, see the kind of specifically more useful things. So you can't, the thing that you can't get out of a log is, okay, what is actually causing an issue? And maybe you can see that things are being slow, that resources are being used, but what exactly, like which route, which part of the app is causing the problem? So here you can see a breakdown. So for example, about a quarter of the time we spent in the data stores, the HTTP, the dark purple, that's us calling other services via HTTP. The Django framework, very efficient, only 0.7%. Then there's custom instrumentation, like for this particular app, and then our app code is only 10%. But this kind of breakdown, you just can't get it from general CPU and RAM metrics or from looking at logs. But then you have, of course, throughput information, how many are errors and so on, and you have transaction info. And particularly interesting here are the percentiles. So if I turn these off for a second, yeah, we see that, okay, on average, it's 130 milliseconds. Oh, we're so fast. But if we turn on the percentiles, we see that 99 percentile is 750. So what does this mean? 95th and 99th percentile are statistical measures that use sampling to try and include more outliers, or to try and guess, well, to try to show you, rather, what's the representative experience for 95% of your users and for 99% of your users. Because the average is skewed by a lot of really fast small transactions like API calls, but maybe your website actually feels a lot slower. And indeed, I mean, this website's doing well, but it's still 99 percentile, still 6 times or so slower than the average. And then finally, as another, like the final overview thing, you can see a list of the transactions. So they are ordered by impact, which is kind of a mix that the APM collector comes up with, but is basically a mixture of how many you're getting, so the throughput, and how long they're taking. So if you're getting many of a certain transaction and it's being just relatively slow, then it will flow to the top here. So already super useful. And to be honest, this is what saved me loads of time back when I had to debug my problem. Now here you see transaction type. I see as well as web requests, you can also see Celery. So if you're running some background tasks, but for those of you who haven't used it, Celery is a Python library for running background jobs or batch jobs. Things like processing image thumbnails or processing video, like anything that can't happen within a web request because it's too slow. And here we can see similar things, similar breakdowns, throughput of tasks, and indeed we can see the tasks and how long they're taking. So now I told you earlier that I have a favorite tool to install first. So ideally, you would have the logs and the metrics all instrumented, but that ideally doesn't always work quite like that in the real world. So now, if you think about it, why do we go to look at logs? Like I used to go to look at logs to look for errors and to look for details of errors. Well, guess what? APM can capture errors as well. So as soon as you instrument your application, it will start sending the errors to the APM server. And not only that, it groups them. So can you imagine looking at 7.5 thousand stack traces for this error, in addition to 3.2 thousand stack traces for this error? It gets a bit much in pure text form. So this grouping is excellent. And all of the vendors have this. So I highly, highly recommend installing an APM. I would actually, if I start a new project, even if it's a throwaway project, I say, oh yeah, it's just a prototype for a new service, whatever. I first put APM because it's also really easy to install. In my opinion, possibly easier than logging to set up. Of course, that varies a lot depending on your taste. But I would do it because that experiment will likely turn into a production service and you might not have time to instrument it properly. And I do the ideal case. So if it was down to me, put APM first. Yes, and so then you can look at the details of each error and so on. It's just like looking at a log. And not only that, but in addition to transaction and error types, it also has basic metrics, at least CPU and RAM, which is 95% of the time what I was looking at. Like someone more rarely had to look at disk and network. So with APM, you already get CPU and RAM metrics. Excellent. So let's move on. Now, for the real user monitoring, there is this super cool thing that we have now in the newer versions. You can actually play along, by the way, if you feel like it at this URL, demoelastic.co. But we have average load duration distribution by country because this lives in the browser. The user downloads it. We can actually track how long it takes for them to interact overall, not just the backend service reply. So we can make a map for you because, as I said, one of the things Elastic got into was maps. So now we have this ability. And this is super cool, I think. Like the fact that you would get it with basically just installing APM and doing a bit of setup. And then on the on the real user monitoring page, you just get this. Like you don't have to, usually in Kibana, if you're used to it, you have to like define a visualization and like make a dashboard. But this is defined for you. Like it will start tracking that information, which I think is awesome. Okay, so then you get into, so basically if we were to, so from here, this is like the Python view, these are all the transactions, right? Now from here, let's click into one of the transactions. Okay, so this is the detail view. This bucketing is super useful because here we have 125,000 normal requests, taking between 0 and 1 second. And we can see a trace sample for a normal request. But here we have something that took 15 to 16 seconds. So these buckets immediately allow you to focus on problematic requests that keep your web workers too busy. All right. So that's excellent. And the request, I guarantee you, will look different to this. There will be probably errors. Now, here we have a feature called distributed tracing. So this is actually looking at some part of the backend. That this is the node service. So the request is coming in, and it's okay. It's actually calling itself again. As you can see, there's another GET request here to Obbean's node. So again to itself, and then that's making a request to the Go service, and that's making a request, and the Go service is in green. And that's making a request to the Python service in purple. Okay, so, and then you can see things like exactly the query that's being issued, which is fantastic. You can often, I can't unfortunately in this particular example, but you can often see the stack trace, so you can actually see exactly where the query is issued from. But most of the time, anyway, just from the function name, like here, Obbean's views order, you'll be able to tell, like what's issuing the query. Hopefully you have a relatively small functions. So this is distributed tracing, where we show you the entire path of the request. This is another fantastic thing. This is achieved by essentially adding specific HTTP headers, special headers, to the request as it comes in. And then if you have each service instrument, that like you have Node agent installed in your Node service, Go agent in your Go service, Python in your Python service, then automatically you don't have to do anything extra. As soon as you install them and they send information to the APM server, to the collector, then it will put that together. You'll be able to see it like this. Okay, and we'll go back to this diagram in a second when we talk about the more technical details. Okay, so this is another extra thing. You can actually, for each transaction, you can put the ID into various logs, and so into trace logs specifically here. But if you're putting your logs in the Elastic Stack as well, and your APM data, your traces, then this integration is excellent because you can immediately click through to the pod logs, the pods for Kubernetes, or containers if you're just using Docker containers in some other way, or you can click through to the metrics, which is fantastic. So now let's say you were to click on trace logs. So this is what that looks like. It will capture, so it will look through all of the logs that are coming in, and it will look for that specific trace ID. So now you'll be able to see logs from whatever service you are sending the logs from into Elasticsearch. You will see it here. You can even do custom logging. So you can actually, when you do logger.error or logger.warn yourself, you can add the transaction or the request ID, or here the trace ID. Like all of them will work. And so when you click through, you will be able to see more information, because not everything works in a kind of strictly predefined UI like this. Sometimes you will need to log more information, a lot more detail in text. And if you add that identifier, you can look for the logs for that specific transaction sample, right? Which is, I think, I haven't used this in production because I was already working at Elastic when I found out about it. But yeah, I think this is quite a good one. Okay, so now that you've seen what an APM is and some of the interesting things you can do with it, let's talk a bit about the technology behind it. How am I doing on time? 20 minutes. Okay. So, agents. They are often installed. They are often a dependency of the web app. So I will show you in a second how it's installed in Flask. They are definitely language specific because they need to collect runtime information, and they are often even framework specific. So they will have some built-in support, but it won't be as magical as just writing a few lines of code if it's an unsupported framework. They collect performance data and errors. We'll see that in a second. And as I said, they send their data to the APM server. Yes, and ideally they have no overhead. So this is really hard because it depends highly on your production setup and your app, really. But what we hear from the field is maybe 3 to 4%, and that's CPU overhead. Ideally, there is extremely little memory overhead, and certainly as little as possible. Like it just tiny, it should be very, very small amounts of milliseconds. In like not slowing your app down, not slowing your ability to respond. And this is tested pretty well, and our consulting arm in Elastic gets information as well from the field about like serious problems if it causes serious performance problems. Okay, so as you saw, they collect SQL queries and of course your HTTP responses, as well as requests that it will make to other services like to Elasticsearch, or if you're using just any kind of third-party service. Now, there's two terms that you should know if you haven't used APMs much, because this is useful. Okay, so there's transaction. You see these two little arrows here on this row? So this is the entire transaction. It represents the entire response that we're building to the request that's coming in. That's the whole thing. But then each transaction, like here in the Python service, so you have the two arrows, so that's the transaction there. But it will have components, or it will have pieces of it. And so those are separate spans in APM terminology. And as far as I'm aware, other vendors also call them same thing. So you have transactions, which are the whole thing, and spans, which are parts. Okay, so the agents, they basically wrap certain operations and they measure the time you spend in there, but I'll show you that anyway. So now, something that's quite useful to understand is, before I dive actually into the code, which is actually surprisingly simple, it's web frameworks. So you've probably heard of Whiskey, WSGI. So this is a protocol that basically once upon a time, Python web frameworks had to talk to web servers, and we had a lot of web servers. So we had, of course, Apache, Nginx, and so on and so forth. But then you also have the application servers like Green Unicorn or Micro WSGI or UWSGI, however you pronounce it. And then you have loads of frameworks. You have like Flask, Django, Bottle, Pyramid, Pylons, yes, tons of them. So how do we ensure interoperability between all of those different components? Well, enter WSGI. The Python community really likes like clean, nice abstractions. It likes to keep its house clean, and so it came up with WSGI. And this is basically says, okay, this is, if you had like a dict that represents the response that the web framework is going to produce, this is what the application server, like Green Unicorn, will expect to take. And then Green Unicorn takes care of talking to Apache and so on. So that's it. It's just an interface. But that matters for us because the standardization helps us. And then finally, we have this. So a request comes in, right? Okay, so it comes in from Apache Nginx, then that hands it over. So we're looking at the left-hand side at the red arrows. Comes in from Apache, hands it over to the WSGI server like Green Unicorn, hands it over to the web framework like Flask, and that hands it over to, importantly, any WSGI middleware. You can do this yourself. You can write middleware files that execute for every request. And this is a fantastic ability because if you're a vendor like Elastic that's trying to capture monitoring information from every request, and there is a mechanism in Python that allows you to run something for every request, you can of course use it. This is excellent. That means we actually don't have to go down to the deep level of technical detail. So thank you to the Python community for building these layers of abstraction and keeping it so clean. Okay. And then the middleware, eventually you get to the app object, which you will know. It's like in the Django, the app object, or in Flask, the app object. And the second row, this is how you instrument the Flask app in Python. Okay, and then it goes back out. So if you follow the green arrows, the app builds a response using your business logic, whatever you've written in your controllers, then goes back out through the middleware, goes back out through the web framework, out to the WSGI server, out to Apache or Nginx or whatever else, and then that finally hands it back to the browser. And so that's the lifetime of a web request. Okay, so finally, let's look at some code. So we're going to have a look at Flask and Celery. So first off, how do you get all of these pretty graphs that I just showed you, at least with Python? Well, this is how. And it's about as easy in JavaScript as well. So you actually, I notice I have not got the requirements open. So of course, you define the dependency, right? So this is how you do it for Flask. And for Django, you just remove the Flask brackets. That's all, just one line. Okay, now it's installed. We have the library. Okay, and then we import the library right here. Make it a bit bigger, right? Okay, yeah, we've imported it. Here we create the Flask app itself. And this is all that we have to do. That's it. So we install the dependency. The only required field here is the service name, so that it knows what to display in the UI I showed you as a service. And you might want, in production, you almost certainly want a server URL, because your APM server collector likely won't be running on the same machine. If you're using Elastic Cloud, so like if you don't want to set up the APM server and Elasticsearch and Kibana and run them, here from cloud, you will get a URL to put in here. Now, this is really important settings. That's it. You don't have to do anything else, then you will get the data that I showed you. Yeah, so that you just wrap the app object in this Elastic APM constructor. Okay, so you wrap the object in the constructor. So let's dive in. Let's see the constructor. So to give an idea of what we are looking at, we go APM agent Python. This is now the code of the APM agent. So Elastic APM module, contrib, because it's a specific library. And first we look at init. Okay, so now before we dive further in, I have made you a nice diagram. Now, you don't have to understand all of it, because we will also go through the code and we will go through the diagram. Okay, so here is the constructor, the init function. And this is what we called when we said Elastic APM brackets app. So then it will call init app, and then we actually just hook into these three hooks. They're provided by the web framework itself. So we don't have to do that. We don't have to dig into abstractions. Oh, what is the request coming in? Is it finished? Is there an error? Oh, no. No, we just leave that to the web framework. Again, thank you, Python community, for the clean distinction of responsibilities. So it will see that in a second. And then we use a couple of interesting functions to basically capture more of the information. But in like altogether, if I was to summarize it, we just use framework hooks, we get some info, and we put it in a dict in memory, and then we send that dict in JSON form to the APM server. That is it. Okay, so let's have a look now at those 5 functions, which would actually take very little time to look at. Here is the init, the constructor that we called Elastic APM brackets. We are here. Okay. Now, if we were given an app, as we did, we gave an app in the brackets in the actual app code. We call init app, and init app is right here. Okay. So here we go. Signals.request started. This is coming from Flask. And we want, whenever there is such an event, we want Flask to call our request started handler. Okay. And the same for request finished, and the same for handling exceptions, which should be. Anyway, let's have a look at the request started. Okay, so here we go. So we do a begin transaction. That's basically, okay, create the dict in memory, please, and get some information and from the beginning, whatever we can get from this transaction. The trace parent is very important. This is how we get the different colored bars and how we trace the request through an entire system of services. That's the magic bit for that. Okay, and then we do get data from request. And so this is in here in utils.py. And you can see it here, and it's pretty simple. Yeah, I told you we'd be creating just the dict in memory. Yeah, and then basically just sending that to the APM server. That's the dict. So here is we're collecting any information. Is it a get, a post, a put, whatever, IP address and other network information, cookies, the headers of the thing. And there is also some custom stuff that you can do. You can like label each request with the extra custom information like username or tier of customer, like do we care more about this customer because they're paying 10 times more to our company. So you can actually label requests like that as well. Okay, so that's it. We build a dict, we return it. Then in request finished, we do an extremely similar thing. So again, remember Flask tells us, basically Flask, this is a callback, right? Flask calls request finished for us pretty much. And so we do get data from response. And that's it. We get the headers and we get the status code. And yeah, that's pretty much it. And set transaction result. This is basically to show a nicer red error in the APM UI. But that's it. We just build a dict. We just take information, from things you already know. Like up here, like get data from request. Like env, the env module. Like I'm not gonna dig into that, but request.method, that comes from Flask. You've used request.method when you've written your own controller functions. Right. Okay. Maybe you haven't used like socket information, but yeah, you get this out of Flask as well. And so the same for this. So there's nothing super magical about how it works because it's all built on top of other things, like on the shoulders of giants, of the people who wrote the difficult things like Flask and Werkzeug and Green Unicorn and so on. Yeah. Okay. Now, let's see how we're doing for time. When did I start? 18:58. Okay, right, should be finishing. Okay, I think I have time though to show you the celery implementation. In fact, however, let me first show you this again, just to kind of drill the point further into your head, so you realize how it's just a few function calls. That is it. So init here. This is right here. This is our app, your Flask app. This line, Elastic APM brackets, give the app object. This is the first rectangle here. That's the init. Okay, well, that goes to init app. That tells, it hooks into the event handlers. It provides event handlers to hook into the events provided by Flask, and those just use a couple of utility functions that make a dict. That's it. Yeah, so that's how it works in Flask. Now, Celery is extremely simple. It's extremely similar, but even simpler. So we just have this register instrumentation. Where are the signals? Yes, okay, exactly the same thing. Celery provides us with these signals: work process init, work process shutdown, and we say connect these handlers, which are functions defined in this file: worker startup, worker shutdown. And they should be. Yes, here they are. Yes. So this is what we do here. So it's very similar. It's all just events. As you can see, like the entire Celery instrumentation is 92 lines. Of course, yes, there is more stuff that goes on in Elastic APM in the base layer, because all of these are kind of specific versions of more abstract classes. But still, like this is what it takes to actually make it work for a specific library. Okay, so we've seen how to instrument, well, you've seen what it is that we are looking at and why it might be useful, and like why for me it's an evolution from logging and metrics. You've seen the actual code, so like how you put it in your web app, the 3 lines that are needed for that in a Python app. As this Django, Flask are supported, as well as async.io actually from, but it's in beta, and it requires Python 3.7. So like those 3, I guess, cover most people. And you've seen how it actually works, which is, yeah, just register some handlers and build a dictionary of information. So maybe not so exciting as you might have thought technically, but that's the point. It's not that difficult. And it's all thanks to like the Python community being so into clean code, and being able to maintain abstractions even across basically different projects and different communities, and being able to coordinate. And that's a really fascinating part, I think, of building any kind of technology. Anyway, so this is so I don't forget to say it. So everything I've shown you is free. You can obviously, if you run it in Elastic Cloud, then it will cost at least a little. And then it depends on resource use, like how much, well, not how much data you're sending, but how much CPU and RAM you're using. So when it starts to explode, only then do you need to increase it, to pay it more. But it is free, and you can also get it yourselves. So that's it. That's the end of my talk, and we're very happy to take questions.
Thank you very much, Emanuil. Was awesome talk. Long one, but I still had to watch all of it. I mean, long in a good sense. I wanted to have my dinner, pizza. Didn't work during the first talk, didn't work during the second talk. You people just have really good content. Okay, so let's wait for the comments and the questions. I also have some myself. Yeah.
Yes. And apologies for going a little bit over the time. It is just so info-packed, and yeah, it needs to be polished.
I have all the time needed. It's you speakers who have limited time, and I still had some food. Now the long story short, I went to buy beer. I bought the beer, but I didn't have time to go to the normal grocery shop to buy the food. However, when I was going like in a drink shop, I saw this, which says, this is food. So I said, maybe if I have difficulties eating my pizza, I can have this. So I'm fine, I'm fit. Thanks again for your talk, and then we can start with my questions. First, I have seen you have this distributed tracing system. Do you have your own protocol, or do you support open tracing?
So open tracing, correct me if I'm wrong, is the draft one, right? Or is that open telemetry? But we tried to collaborate. Okay, we tried to collaborate with all open standards that come out. So yes, so actually we do support open tracing, and I know this because I have seen it in the Python agent docs, and I'm just checking it. And indeed, yes, Open Tracing API, Elastic APM Open Tracing Bridge. So if you just Google Elastic APM Python Open Tracing, you'll get the docs for that. And yes, we do support it. Yeah,
That's
Elastic
nice.
always tries to go ahead with whatever is whatever efforts are going on at like open collaboration. Oh, I remember the name. So there's open open tracing, there's open census, and there's open telemetry. I think open telemetry is the new one that like everybody is sort of trying to rally around. But the last I checked, it was like draft. Yes, that's the open telemetry. So we're working also on that. But since it's draft, we don't have like anything production published yet.
I see.
Nobody does. So yes, but we're trying to stay on top of it. Yes.
Okay. There was also sort of a question I had, but I think you answered it about support of the asynchronous frameworks. If you say you are supporting async.io, I guess that's covered. But how about the older frameworks like Django? You typically had a very simple, straightforward middleware setup where you have the entry point and the exit point. Now you can also use Django asynchronously with asynchronous views that run on the event loop. I'm not sure if that's already covered with your agent.
That's a good question. You asked really good technical questions. I would guess so. So I don't. First off, I don't know. I would guess so because in Django the setup's really similar. It's basically signals.request started and signals.request finished, and I would assume that Django would fire those just at the appropriate points, right? So even though the execution model is totally different, those callbacks would still fire, and so we would hook into those. So yeah, abstractions. I'm pretty sure.
I have no idea how it works, to be honest. The Django async thing is new, so I just know it's totally different execution model. That's why I was wondering if that was even realistic to port the agent.
No, well, so I mean, it would be. I just don't know how well it would. I haven't tried it yet with async Django. Yeah, async.io. Yeah, that's beta support, and there's also Starlet and Fast API support. So I would guess that it would work. But
all right, let's write down this promise.
Yes, but
if not, we get back to you.
Absolutely, yes. I'm here for the complaints. That totally is really part of my job.
Good. Yeah. We still don't have any questions and comments. Now it's your last chance to post something. I mean, it was a big piece of information, so I guess it's hard to focus on something little. But I did focus, in fact, so I have more. This is more of a setup question. I guess many people would be trying to integrate clean tools in their hobby projects or like pets, little startups, let's call it this way, since beginning, and tracing would be one of them. Could be that many people do not want to pay for it right away, so they just host it and they think if we need it, we upgrade. What limits will these people hit first? So when it's time to go to the cloud version, to the hosted version of Elastic Stack, as opposed to the like when the bell rings, like, hey, now you're big enough, the trouble is coming.
That's a good question. It really depends a lot on the app and how much traffic you're getting. There isn't like a, oh yeah, if you have like 1,000 transactions per second, then now you have to do it. Yeah.
Let's say what limits you usually hit first? Is that disk storage because you need to store all of the logs and stats? Is it the memory? Is it the CPU? What would be generally a tip for people who set it up themselves on their hosted own server?
I would, so for, it's a good question again, that it again depends a lot. I wouldn't have, but because it's meant to have quite a low overhead, like the agents are meant to have quite a low overhead, and like the server doesn't really take that much CPU and RAM to run. I guess probably disk, especially if you're hosting it at home or like on spinning disk. because that will, like, if as you spin up to hundreds of requests, especially per second, let's say, okay, you're okay at 100 requests a minute, which like a lot of smaller apps, this is totally reasonable. And if you go to 100 a second, not to mention 1,000 a second, then it's just like, so it does do sampling, so it won't sample all of them, but you will start just seeing it kind of struggle to record. But there is actually a parameter you can like adjust how many transactions it samples. So like 1 out of 5, 1 out of 10, 1 out of 20. Yeah. So if you have a lot that are similar, you can adjust that and buy yourself more time from like having to move to cloud. Yeah. So yes, so it's really hard to say. That basically, when it starts annoying you, and maybe on the second or third time it annoys you, and with resource use, then consider moving. But it's really hard to give a specific answer to that because it depends so much.
Of course. I still have one more question, I think, but I forgot it.
Oh, well.
Good. Lisa, are you still online?
Yeah.
Oh, all right, great. We will just attach you here in discussion, so now people can also see you and hear you as well. I thought maybe either you have questions to Emanuil or Emanuil has questions to you. Now we have a little discussion time, so it's like off format before we go to,
Yeah, I don't have a question. I just wanted to share a comment that I really like this live demonstration of products or some model things you showed today. This is much more fun than just watching slides when something really works and you can click and watch what's going on here. Great presentation. Thanks.
Cool. Yeah, I absolutely agree.
It's a struggle at this point. The talk is a bit longer, but because I want to show what it is, because actually so many web devs are still just using like logs and metrics at this, but you can, there is even a free tool, like you can just get it, but many people don't know what it is. So I can't just like dive into how it works, and people don't know what I'm showing, how it works.
It's a good format. It's a good format. The difficult part was just to have to get so many information, because when you are showing, for instance, the Elastic Stack, I think, all right, maybe I should ask about this. Then bam, open tracing. I have a question about this. Then bam, codes. And I think, oh, that was all not so important. Now the hot part comes, and like it's so much content, and then you have to choose what's to focus on, because
that's fair enough.
I'm not such an expert in this field.
I had again like not a question, but thank you for Lisa. It was a fascinating talk. I've always been interested in how like runtimes work and how like any of this stuff works, and it was really interesting to learn from you. And also, I wanted to say like a huge thank you for the Python debugger in PyCharm. Of course, is because I have a story about this. So when we were like, when I was running the consultancy, and me and one of my partners, we were working this difficult problem, actually for the same nonprofit whose app fell over repeatedly for 4 days. We were just like, it just got too much. One second. So it just got too much for us, and to do just print statements. The debugger like saved our asses, and this is when we started using it. And we should have used it earlier. It's a free tool. It's available, or kind of like APM, I guess. We should have just used it, but no, like because you have the habits,
Yeah.
So, I'm also thank you. I have also a PyCharm subscription, and that's hard because we do a conference here in Munich. Microsoft is hosting us. They had really good sessions on our meetups about VS Code, but there is also JetBrains where we also do a lot of meetups, and I have both just to keep it fair. But yeah, actually there are some tools in PyCharm that I didn't find so good in VS Code. One is the DB connection. It exists as a plugin also in VS Code, but for me it's just not so comfy. Also, the Amazon tools for me somehow are easier to use in PyCharm.
Yeah.
But VS Code
say...
needs less resources, I have to say that as well.
Yeah, I would say they're just a bit different tools. Like VS Code or some other text editors, they're great for editing, I don't know, 1 or 2 files. If you just need to open it, quickly edit it, close it, and that's it. But if you have a really huge project and you want, for example, rename some function and, well, you need properly find usages of this function and rename it and analyze your code, well, I think PyCharm is much more powerful in these cases. So both tools are great, but they have different, well, targets, yeah, and different tasks to solve. Yeah.
Apart from that, there is a premium support in Munich because there are often Python meetups hosted by JetBrains where you can ask Dmitry, for instance. I had issues. My PyCharm was crazy slow, like super slow. I thought that's not the way it should work. I wrote email to Dmitry. He sent me the way to increase the RAM limit. Problem solved. Like 1 hour gone. Call it Spatial Munich Community Premium Support.
Yeah. Send an email to PyCharm team lead. Yeah.
Good.
Yeah.
Okay, now I guess we need to say thanks to Gena, who was I don't know if he's still in the call or not. Gena, it's different from Boris, who is usually supporting us. Boris is a developer with a music hobby, so he plays drums. Today he can't join, so I asked for big favor to Gena. Gena is a musician with tech hobby, so that's a bit different world. So he had to go today to his studio, sit there just for us to have a bit more fun this little second. You will see that when you watch the broadcast again. But anyway, I want to say thank you again. This was okay. This was a great performance. And thank you. And if our audience liked it, then drop something in comments, because I think there is a chance that I can convince him another time to join us, maybe with a solo. Today there was no solo because of short notice. There could be the next time or next time, but that's only if we ask him nicely. Hopefully with a webcam. So that will be interesting to see. Now I'm publishing the link. Let me check, where is it? A link to Skype. Actually, this is this Skype call that we have. It's right here on the screen, and it's also in comments, and it's also in the description. If you hit that link, it will drop you to the Skype call where we all are on the background. Now I will stop this YouTube stream in a minute or so, saying a big thanks to everybody, and we can still chat off record in Skype as long as somebody stays there. I guess Skype works till the last visitor. That's usually me. So everybody is very welcome to join us there. For now, I'm saying again, big thank you to the speakers, as well as to the community watching us at the moment. Thanks for your thumbs ups. Thanks for sharing as well. And I see you next Thursday. We have 3 speakers. It will be later, 1 hour later. It will be like more late night show. We have 3 speakers, and I will publish the announcement tomorrow, I guess. So thanks again, everybody. Let's clap our hands.
Thank you.
And I see you. Ciao.
Thank you for hosting, Anton.
Yeah, Anton, thank you for organizing.